Hi viewers, this is Sri Ramlu. So before watching this video, please subscribe my channel, like it, and share it to your friends. Now the today's topic is very important in this chapter, that is Maxwell's thermodynamic relations. There are the four relations we have, and these four relations can be obtained from the thermodynamic potential. The friends, before watching this video, first you must watch the video thermodynamic potentials. Why? Because if you know the thermodynamic potential, then only you can understand the Maxwell's thermodynamic relations. Okay, so now let me start Maxwell's thermodynamic relations. The differential relation among four basic thermodynamic coordinates P, V, T, and S are known as Maxwell thermodynamic relations. Okay, so this is the definition. What is that? Differential relation, that is among four basic thermodynamic coordinates. So these are the four basic coordinates, and that is called Maxwell's thermodynamic relations. So first, Maxwell first thermodynamic relation. How can we calculate this relation? Now, so in from thermodynamic potential, first potential is internal energy, and there we have change in internal energy also. That is I am going to use here to calculate Maxwell's first thermodynamic relation. So friends, that is why I am saying please watch the video thermodynamic relation first and then come to this video. So that is a change in internal energy is given by du is equals to TdS minus PdV. This is also called as a first and a second thermodynamic relation. Taking partial differential of u with respect to S and V. Why with respect to S and V we have to take? Because here after the whatever you have, okay, so that is here we have to take. So first time you have to keep one S is constant, and then you get one relation, and next if you keep the V constant, then you may get another relation. So like this, by using these two only, we can get thermodynamic relations. Okay, so like that is why I am taking here the two partial differentiation S and V. Okay, they doing the partial differential to u with respect to S and V. First S and then V. When you are doing with S, then keep it as V as constant. When you are doing a partial differential with V, then keep it S as constant. Now see here. So here what I am doing, okay, just now what I told you, like this only. Now what I am doing, I am going to do the differential equation with respect to S by keeping V constant. So if we keep the V constant, then differentiation of the V, what happens? It becomes 0. Okay, so then this word cannot appear to you, it disappear. Then you get du is equals to TdS only. Alright, and TdS, among the TdS, bring ds this side, then du by ds is equals to T get. So right, so see, this is okay. So like this you have to calculate, and next time see, second time keep S is constant and do differential with V only. When you keep S constant, it's a differentiation, what happens? It becomes 0. Okay, when S constant, it's a differentiation, ds is 0, then this term cannot appear. Then du is equals to minus PdV. Now what is du is equals to minus PdV? You get minus PdV. And now what you have to do, keep P this side only and bring dV this side, then du by dV you get du by dV is equals to minus P. So that is why du by d is equals to minus P. But here instead of d, taking d, here what I said, partial. For partial, instead of writing d, simply write it as dou only. That is the difference. Dou u by dou. Yes, its mean is at constant volume. Dou u by dou v. it mean is at constant, yes, entropy. So that is why we get like this. Now if du is perfect or exact differential equation, then we get, so already we know the differential equation, exact differential equation. I think if you are belongs to the MPC students, and you can easily you know the what is exact equations. Why? Because in degree only you may get exact equations, exact differential equations. All right, so please keep in mind exact differential equations from the mathematics. So it is the exact differential equation. Dou by dou v of dou u by dou s is equals to dou by dou s of dou u by dou v. For this only, for this. Why? Because this equation is different for different relations. Okay, so for this only, for this what, actually whatever it has right here, and this is also right here. Okay, so this is here and this is here. Am right? And whatever constant present here with respect to this only, differentiate it. Whatever constant present here with respect to this only, differentiate it. So please keep it mind like this only. And you know this value, this value is what, t. So in the place of this we write t mean, then dou t by dou v like this. And we know this value, dou u by dou v at constant s, that is minus p. So it becomes minus dou p by dou s. So like this we get. Okay friends, so this is what it is, Maxwell first relation. Okay, so at the end I will explain its logic. No need to remember by heart it. Simply I will give one logic. By using that logic only you can remember all the relations, four relations you can easily understand, easily remember. Okay, next, Maxwell's second thermodynamic relations. What is this? For this what I am doing, I am taking enthalpy, right? In thermodynamic potential, if you see thermodynamic potential, second potential is enthalpy only. So whatever there, same will present here, and by using those only I can calculate my thermodynamic relations. The change in enthalpy is given by, so dH is equals to TdS plus VdP. So please watch that video, then only you can understand this one. So I am here I have taken only formula directly without doing any differential equations. Now what I have done here, in the same manner I am going to do here, same process, no change in process. Here s and p are there, so I am going to do the differential equation to the h with respect to s and a p. When we are doing with respect to s, why then keep p constant. When you are doing a differential equation with respect to p, then keep s as constant. Okay, please keep it in mind. Right, see here. So when p is constant, then what happens, it's a dp, it means the differential of p is becomes 0. So then this term cannot disappear. Then what, dh is equals to tds. In tds bring ds this side, dou h by dou, yes, write it, d becomes right dou as. So dou h by dou s is equals to t when at p is constant only. So this dou h by dou s is equals to t at constant p. And next one, now for second one, now keep s as constant, then its differential equation is 0. Then this term cannot appear to you, it becomes 0. Then dh is equals to vdp, bring dp this side, dh by dp becomes dou h by dou p is equals to v at constant, yes, right, see here, dou h by dou p at constant is equals to v. Now partial differential equation, how do we have exact differential equation? Exact mean equal. How do we have to write? Exact or perfect equation. So take this is here and this is here. What you have constant here, with this constant differentiate here. We here with this constant differentiate it here, partial differentiation, and make them equal. This is a exact or perfect differential equation. Now in this place write this value, then you can get dou t by dou p, and in this equation write v, then it becomes dou v by dou s. And how do we have to write this p and s? Here p you have write opposite term, right? So here yes you have write this term here like this. Okay friends, so like this you have to write constants. And next, third, Maxwell thermodynamic relation. Maxwell thermodynamic relations. The change in Helmholtz function is given by. It is the third one. This is also third one in thermodynamic potential. Please watch thermodynamic potential. The change in Helmholtz function is given by dF is equals to minus PdV minus SdT. Now what we have to do, we have to differentiate with respect to V and T. Try it like this. Now while doing with respect to V, keep T as constant. While doing the differentiation with respect to T, keep V as constant. Okay. Okay. Now see. Now now let me do with respect to V. Then what have to do? Have to keep T as constant. Then if T constant, dt becomes 0. Then this term is totally 0. Then what do you get? dF is equals to minus pdv. Bring this dv this side. df by dv becomes right dou. Okay, for the d, right dou. Dou f by dou v is equals to minus v. Like this. Next, same test. Next, see here. Next time. If T is constant, no, if V is constant, now if V is constant, then what happens? Its differentiation is 0. Constant differentiation is always 0. Now this total term becomes 0. Then next what you get? dF is equals to minus SdT. Bring this dt this side and write it as dou. Dou f by dou t is equals to minus v. I am right. Dou f by dou t is equals to minus v. At constant v, we kept it as constant. That is why right here like this. Now exact differential equation. How do we write exact differential equation? See here. Write it is first as it is, and this is also as it is. So whatever constant present with this differentiated partial differentiation, whatever constant present this side, differentiate with this constant partial differentiation, and it is called exact or perfect differential equation. Now substitute this value here and this value in this place, then what you get? If you substitute minus p, minus dou p by dou t, and if we write here minus dou s by dou v, minus gets cancelled on either side. So that is why dou p by dou t is equals to dou s by dou v. How do write it? This constant, this v right here constant, and this t right here constant. Okay friends, so this is what third thermodynamic Maxwell relation. Next one, last one, that is the fourth one. Now see the fourth one. The fourth one can be obtained from the Gibbs function from in thermodynamic potential. So thermodynamic potentials are important to us. To if you understand these equations, then you must you must by heart thermodynamic potential. Now change in Gibbs function is given by dg is equals to vdp minus sdt. It is what? Change in Gibbs function. Everything, everywhere I have taken change only. Here, everywhere. Here change I have taken. Here also change. Here also change I have taken. Okay. So dg is equals to vdp minus sdt. Now what? Taking partial differentiation of g with respect to pt. So what? It is p and it is t. First keep a t constant. First keep t constant. If t constant, then it's a differentiation, dt becomes 0. Then what happens? This total term is becomes 0. Okay. So now dg is equals to vdp you get, and dp bring this side and write it as dou d becomes dou. Then dou g by dou p is equals to v you get. At where? At constant t only. So that is why here constant is written. And next, now keep p constant. Then its differentiation becomes 0. And now what happens? vdp completely 0. Then sdt you get. dg is equals to minus sdt. And dt this right this side and becomes it is a dou. Then dou g by dou t is equals to minus s you get. Okay friends, like this. And a perfect differential equation, how do we write? First write this one as it is, and what constant you have with this constant differentiate it partial, and here p differentiation of partial differentiation. Now in this place write v value, this v value, and here minus s, here minus s, it come this side minus only, and here what v means it is a dou v by dou t. It is here already dou by dou p is there in this place. what you get? Minus s, minus written outside, it become dou s by dou p. And constant, how do you write? Write this constant this side, and this is as constant this side. Okay friends, so it is Maxwell fourth relation. Okay, and now finally, how do we have to remember whole formula? So this is the logic. Okay friends, so by using this logic we can remember all the formula. And what is this logic? First, draw a rectangular shape like this, and write here PSTV, police station TV. So it is a police station. P means police, S means station, T means tele, V means vision, television. Okay, police station TV. Okay, in police station there is a TV, that is the meaning of this. And what channel is running there? G channel is running. G channel. G channel means Z, you may write like this in channel. So if you want to see the TV, G channel like this present, and it's reverse it. Reverse is like this. Okay, that means here to start, it is a first equation, it gives first equation, second equation, third equation, fourth equation, like this it gives. But first equation and fourth equation becomes minus, and third and second and third are always plus. Second and third are plus. Okay, now let me check. It is a fourth equation. I want to check how can I get this formula from this diagram. Where we have fourth equation, this is a fourth. Here I have written 4, means stand here this side. So let you are here. Okay, and you are here means you are here. So these two terms are first term for you, and the remaining are the second term. Write these two terms this term in numerator, and its corresponding by denominator. It is numerator, denominator. It means, and attach them. Dou s by dou p is equals to dou v by dou t, like this. Okay, dou s by dou p is equals to dou v by dou t. See, dou v by dou t, dou s by dou p, and it is minus, so that is why here minus is written. Okay, so next one, next check, let me check next one. Next, if I want to third, let me write third one. Third one means where you have third number this side, so that means understand you are standing this side. Okay, you are here. So first term this is, and second term, first term, second term. Write in numerator, denominator, numerator, denominator, that's it, and attach dou terms. Okay, now it is what? So it is a plus. First, dou p by dou t, right? Dou p by dou t is equals to dou p by t over, next s by v, dou s by dou v, dou s by dou v. And constant terms we have to write. How do we write constant terms? It is t, right here t constant. It is v, right here v constant. So third relation is what? Dou p by dou t at constant v, dou s by dou v at constant t. See here, check, let me check. See, this is dou p by dou t, dou p by dou t, dou s by dou v, dou s by dou v at constant t, at constant t, here at constant v, at constant v. Okay friends, so like this, if you want to check, you can check all the equations, you may get exactly exact value you can get. So by if you don't know while writing examination, but just keep in mind this diagram and then write it. Okay friends, thank you. Don't forget watching this video till the end.